What is angle, angle, side, and when do you use it? So by now you should know what AAS represents. I'm not going to write it down, but I will remind you that this is for task 6.9, and this should go at the top of your paper, or it should already be there because this is the 4th video for the installment. Okay, this is a reminder of what your notes should look like, and we've already gone through video 1, video 2, and video 3, so this is actually video title number 4. It should be at the bottom. And then don't forget, after you've gone through all the videos, that you review your notes and create a summary from what you learned. Okay, for our last postulate, we're going to talk about angle, side, angle. And so we're going to compare these two triangles. I really think by now you can do this on your own, but I'll help you do it. So we're talking about the angle, angle, and side. And notice that the angle is going to be included between an angle and a side. So now let's go ahead and take a look. The angle that we're first going to look at is angle C is congruent to angle Z. So angle C is congruent to angle Z. Angle A is congruent to angle X. So angle A is congruent to angle X. And now that we've talked about two angles, we can talk about the side. And remember that this angle, like angle A and angle X, was included between this side and that other angle. And then we can say that side AB is congruent to side XY. And so now that we know that we have an angle and another angle and another side congruent to each other, we can say that triangle ABC is congruent to triangle XYZ by angle, angle, side. Here's a more formal definition from your textbook. Angle, angle, side theorem. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another. So I was a little bit mistaken. It's not really included, but you do notice that you have the two angles and then you go to a side. So that helps me. So this part is non-included. And side of another triangle, then the triangles are then congruent, okay? And notice that this one is not a postulate. I was also mistaken about that. This one is a theorem now. It's a theorem. So that means that it's already been proved for all cases, and we're going to accept it as a theorem instead of a postulate. Go ahead and pause the video. Make sure that you have all the information written down on a piece of paper, or on your notes, not just a piece of paper, but your notes. And then go ahead and follow with what I'm doing here. So let's go through the proof of an angle, angle, side theorem. So this is why it's called a theorem, is because there's an actual proof for it. There wasn't proofs for the postulates, but there's a proof for this theorem. So if we're given that angle A is congruent to angle X, so angle A is congruent to angle X, angle B is congruent to angle Y, so B is congruent to Y, and BC is congruent to YZ. So BC is congruent to YZ. Then we can prove that these two triangles are congruent. So we're given that angle A is congruent to angle X, we're given that angle B is congruent to angle Y, and then we're also given that BC is congruent to X or YZ. Notice in this case, the three boxes that we start off with are what's all given to us. And notice this flow proof is going sideways instead of up and down. So since we can conclude that these angles, this angle equals this one, B equals Y, and B side BC and YZ equal each other, we can also say that angle C is congruent to angle Z. And the theorem that helps us to prove this, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if we have X to Y, or X to A and Y to B, then Z and C should also be congruent. Notice that I was a little bit mistaken about this given part. What helps us to prove this, or what helps us to go from deductive reasoning, was these two given values. And then if we use all the things that are given to us, including this angle, these angles, and this side, we can then see that angle, side, angle postulate would give us congruent triangles as well. So we kind of used a postulate to show that they're congruent triangles, but we also explained how the angle, and the side would also prove that they're congruent triangles. I went through that kind of fast because I know there's a lot of videos for this section. So if you had some difficulty, make sure you bring your questions to class and you re-watch the video and add some additional notes.